Hi guys, welcome to Lesson 6.1, Solving Systems of Equations by Graphing. Our objectives for today is going to be able to solve a system of equations by graphing. And this is both an 8th grade and an algebra standard. So yay, you're doing 2 classes at once. All right, so a system of equations is one or more linear equation relating the same variables. All right, sorry, two or more equations relating the same variables. So for the purposes of our class, we are only going to deal with systems with 2 equations, and we are only going to be dealing with linear equations in these systems. When you get to Algebra 2, and maybe in Geometry, but I think it'll be mainly Algebra 2, you'll look at systems of equations that have quadratics and linears, maybe things that are cubed, all kinds of other weird stuff. So that's not for us to deal with. So the solution of a system is the x and y coordinates that make all of the equations in the system true. So this will be one single point that would make all of the equations in a system true. And like I said, we're only going to be dealing with 2 equations for this year. So you would be looking for an equation that works, or a point that works in both of our equations. So let's get started. Today, like I said, we're going to be using graphing as our method of solving. So we need to first figure out how we're going to graph our 2 equations. So we have y equals 3x minus 5 is one equation, and y equals negative 2x plus 5 as our other equation. So let's just start and identify what is our slope, what is our y-intercept. So the slope is what's attached to the x. So we have the slope for one equation is 3, and the slope for the other equation is negative 2. And our y-intercept is negative 5 for our first equation and positive 5 for our second. So now we're going to use those 2 pieces of information for each equation, and we are going to actually graph them. Oh, look, Mrs. Urzo's class, nice graphs. Don't complain. All right. So we're going to graph both equations. So the first equation, we have a y-intercept at negative 5. So we're going to put a point at negative 5. And our slope, is a positive 3. So we're going to go up 3 and to the right 1. Up 3 to the right 1. And once you have 3 points or 4, you can use your straight edge to draw in your line. Okay. And let's make sure we go all the way to the edge of the grid. There we go. All right. Now, our second line had a y-intercept of positive 5. So we put a point at positive 5. And our slope is a negative 2. So we're going down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. So we need to graph that line as well. So now we can clearly see there is a point where both of those lines intersect one another. And the coordinates of that point are going to be positive 2 and positive 1. So now we can double check our answers for all systems of equations by simply plugging the point into our equations. And if it works for both equations, it is actually our point. So we plug in 1 for y. So 1 equals 3 times 2 minus 5. 3 times 2 is 6. So 1 is equal to 6 minus 5. Is 1 equal to 1? Yes, it is. So we're going to plug it into our second equation. 1 is equal to negative 2 times 2 plus 5. 1 is equal to negative 2 times 2 is negative 4 plus 5. So 1 is equal to 1. our equations both, or a point works in both equations, so that is our solution. All right, so now we've got 4 examples on this page to work through, and we're going to do the first 2 as leading you on, and then the second 2 you guys can do on your own. So our letter A, y equals 2x minus 4. So our y-intercept is -4, so we're going to put a point at -4. And our slope is +2, so we're going up 2 and to the right 1, up 2 and to the right 1. Okay. Make sure your graphs are going all the way to the edge of your grid. All right, now the second equation, y equals -1/2x plus 1, so we have a point at +1, and we're going down 1 and to the right 2. Down 1 to the right 2. And now we can, again, draw our line in.
If I could pick up the ruler.
All right, and we can see that that line crosses right there in the middle, so our coordinates are going to be 2, 0. So when you are answering a system of equations, I am looking for the ordered pair that makes the equation true. I don't want just the graph. I want you to tell me 2, 0 is the point in which they cross. All right, so let's do letter B. We've got a y-intercept at -5 and a slope of 1. So we're going to go up 1 over 1 each time. So that makes an easy line to draw. Our second equation, we have y equals -2x plus 4. So we have a y-intercept at +4 and a slope of -2. So we're down 2 over 1, down 2 over 1, down 2 over 1. Hey, look, there's our intersection point. Draw the line in. Okay. And our intersection, our solution is going to be the point 3, -2. All right, so you need to be writing 3, -2 as an ordered pair on your sheet. All right, now I want you guys to try letter C and D, and then we are going to go over them. All right. Letter C, we have a point at -1. That's our y-intercept, and our slope is a +2, so we're going to go up 2 and over 1. We connect our dots. All right, and our second equation, we have a point at +5 and a slope of -1, so down 1 and to the right 1. Connect our dots. And we find our solution is at the point +2, +3. Okay. Letter D, we have y equals x minus 2, so we have a y-intercept at -2. And we have a slope of a +1. Okay. Our second equation, we have a point at +1 and a slope of -2. So we're going down 2 and to the right 1. And we connect our lines. Connect our dots, make a line. And our solution is at 1, -1. All right. Now, these were all nice and set up for us in slope-intercept form. The next question we're going to ask ourselves is, what if, and of course, if it's what if, it's Mr. Boland asking you this question, what if they're not in slope-intercept form? So if they're in, for example, standard form, like these two equations are, So if we're going to do that, we need to get one or both of them, if necessary, into slope-intercept form in order to graph them. So we're going to start off by subtracting 5x from both sides of our equation.
Yeah. Almost jumped a step there.
All right. And we've got 3y is equal to negative 5x plus 9. Now we're going to divide both sides of our equation by 3. And our equation is y equals negative 5/3 x plus 3. Okay. Our second equation, we're going to add x to both sides. And so we get 3y is equal to x minus 9. Divide both sides by 3. Y is equal to 1/3 x minus 3. Okay. So now we're going to use those two equations where you can rewrite them here. So we have y equals negative 5/3 x plus 3. So the slope of that line is going to be negative 5/3. And this is one of those times where writing it as a fraction is much, much easier for us to work with. Our y-intercept is a positive 3. Okay, so our equation for our second line is y equals 1/3 x minus 3. Slope is 1/3. And our y-intercept is negative 3. All right, so now we need to graph these two equations. All right, so we're going to start with our first line. We've got y equals, so we got a point at positive 3. And our slope was negative 5/3, so we're going to go down 5. And to the right 3. Down 5. To the right 3. All right, now we're drawing our straight line in. Make sure you guys are using a straight edge. Unlike that first video in chapter 5 where I used a pencil. It was a straight pencil. All right.
It works.
Our second equation has a y-intercept at negative 3. And the slope is 1/3. So we're going up 1 and to the right 3. Up 1 and to the right 3. So we connect our dots. And we find that we have a point at 3, negative 2 as our solution. So we want to check to make sure they work, so we're going to plug it into both equations. So negative 2 is equal to negative 5/3 times 3 plus 3. So negative 2 is equal to negative 5 plus 3. So negative 2 is equal to negative 2. That is correct.
In the wrong color, but...
Yeah, that's all right. So we've got y equals 1/3 x. So we're going to plug this one in. So we plug in... All right, so we're going to plug in it's negative 2 for y, and 1/3 times 3 minus 3. So now we got negative 2 is equal to 1 minus 3. So negative 2 is equal to negative 2. There we go. We have verified that that is a solution to both questions. All right, now I want you guys to do letters E and F on your own, and then we will go over them. All right, so in our first section, letter E, we have one equation already in slope-intercept form, but the other one isn't, so we need to convert it. And what we're going to do is add 2x to both sides of our equation. So if you want to write it off to the right-hand side, so we have negative 2x plus y equals negative 4. So we're going to add 2x to both sides. And y is equal to 2x minus 4. So we have a y-intercept of negative 4 and a slope of positive 2. So we're going up 2 and over 1.
Ooh, that's not that straight.
All right. And our second equation already was in slope-intercept form, so we have a y-intercept at positive 1, and our slope was negative 1/2, so we're going down 1 and to the right 2. And we can connect those dots. And we have a solution clearly right there at 2, 0. Okay, letter F, we're going to have to convert both of our equations, but that first one is pretty easy. All we got to do is add x to both sides. So we're going to get y is equal to x minus 5. And our second equation is also pretty easy. We just need to subtract 2x from both sides on that one. So we get y is equal to negative 2x plus 4. So we're going to start with the first equation. We're going to graph it. We have a point at negative 5 and a slope of positive 1. So we're going up 1 over 1 each time. All right. Next one, we have a slope at positive 4. And we're going down 2 and over 1 every time. And we find that our solution is going to be at 3, negative 2. All right. So now let's go on to our next question, which is writing a system of equations. Now, how do we come up with something that has two equations? And I'll be honest, this one is not very pretty to graph, but we'll do it anyways. So one satellite radio service charges $10 per month plus an activation fee of $20. The second service charges $11 per month plus an activation fee of $15. In what month will the cost of the services be the same? So this is what we're trying to figure out. So we're going to put our months on our y or x-axis, and we're going to use a scale of 1. So I just write every other number, 1, 3, 5, 7, 9. On our y-axis, we're going to put our cost in dollars. Make sure you are including your units. And we're going to go up. Every single line is 5. So I'm going to just write the even numbers. We'll write 10, 20, 30, etc. All right. So now we need to come up with two equations. So one company is charging $10 a month plus an activation fee of $20. So that's going to be y equals, so we're $10 per month, and months are our x variable, so it's 10x plus 20, because that's a one-time fee. All right. Our second company was $11 per month, so 11x plus 15. So a lower activation fee, but more per month. So now we need to graph these. The red line is going to be a little easier to graph. So we have a y-intercept of 20. So we have a point at 20. And we're going up 10 and over 1. So it'll be 30 and 1, 40 and 2, 50 and 3, etc. Okay, so that's our line there. And we've got a second line that we got to draw, which is 11x plus 15. So we have a y-intercept at 15. Now, going up 11 is going to be kind of tough. But I'm going to just cheat, and since we've got intervals of 5, I'm going to say let's toss in 5 months. So 5 months would give us 11 times 5 is 55. Plus 15, well 55 plus 15 is 70. So that's a nice even number for us to graph with. So we have 5 and 70. And
Or was my line, I think my red line was a little bit off here.
Yeah.
And that is why it is insanely important to make sure your lines are
Precise.
straight.
Yep. All right.
All right.
So now we've got our y-intercept, and we've got our 1 point to work with. So you can see why this wasn't a super friendly example, because it's a pretty tight little window there that we're looking for. And it turns out that that point of 5,70, 5 months, and $70 is where our two lines intersect. So you have the question that was asked was, in what month was the cost of the service the same? We can say the 5th month. And if there was a follow-up question of how much was it, we would say $70. All right. So our second example, we have, suppose one puppy weighs 5 pounds at birth and grows at a rate of 0.25 pounds per month over the first several months. Another puppy weighs 4 pounds at birth and grows at a rate of half a pound per month. After how many months will the puppies weigh the same amount? So our first equation, we are growing at a rate of 0.25 pounds per month. So it'll be 0.25x plus 5. And our second equation is going to be 0.5x, because it's growing at a half a pound per month, plus 4. So now we need to set up our graph. So our x values are going to be months, so we're going to go 1, 3, 5, 7, 9. Our y values, I would go by half a pound increments. So each line would be half a pound, so we'll do every other. We'll just do the whole numbers, 1, 2, 3, 4, 5, 6, all the way on up to 10, or 7. All right. So now we need to graph our points. So we have 0.25x plus 5. So we have a y-intercept at 5, and we are going up half a pound. So we're going to go halfway, or a quarter of a pound, so we're halfway between the next line. All right, at 2 months, we're going to be at 5.5 pounds, so we can put a point there.
So you're saying right here. Haha.
Well, no. Because at 2 months, it'll be at 5.5, because we're adding a quarter pound each month.
Oh, I was confusing the colors. I had it right to start with.
All right.
Okay.
Sorry, guys. I had the opposite colors of what Mr. Wolf had on my note sheet here.
Well, I can just make sure I make my line straight enough. Try and recover. There. Looks better than my last one.
Okay. So now our second line, we need to start at a y-intercept of 4. And now we're going up by a half a pound per. So we're going to go up 1 line each month. And it looks like we have an intersection point there, which is good because that is our goal. All right, so it looks like after 4 months, those puppies are going to weigh the same amount. And if we were to ask a follow-up question of how much do they weigh, well, we look at that point and we go off to the left to our scale and we see that it is 6 pounds. All right. Next page. Problems with infinitely many solutions or no solutions. So we're going to do the same thing that we did before. So we have we've got y equals negative x minus 3, so we have a y-intercept of negative 3, and a slope of negative 1, so we're going down 1 and to the right 1 each time. And our other line, we have a y-intercept of 5, and a slope of negative 1, so we're going down 1 and to the right 1 each time. So this graph, we can clearly see, is going to have no solution. So you would write no solution there. Because those are parallel lines, they will never, ever cross. Never, never, never. All right. Letter B, we've got one equation in slope-intercept form, one equation in kind of slope-intercept form. So we need to get that y by itself in the second equation. So we're going to divide both sides by 3. And we get y equals 3x minus 3. So we're going to have a y-intercept at -3. And a slope of 3. So we're going to go up 3 and to the right 1. And up 3 and to the right 1. Okay. All right, so now when we go to graph our second line, we're going to have a y-intercept at -3. And we have a slope of 3, so we're going to go up 3 and over 1, and up 3 and over 1. And we're going to draw that line in. Huh. Those are the same line. So when those are the same line, we are going to say infinitely many solutions, IMS. So if you remember back to when we were doing solving equations back in chapter 2, and we were coming up with no solution and infinitely many solutions, haha, you guys were doing solving systems of equations and you didn't even know it. We're evil like that. All right, so before graphing these two equations, how can we have determined whether they were going to have one infinitely many or no solutions? So if there's one solution that if we're going to have one solution, the two equations will have different slopes. Okay, so if we're having infinitely many solutions, IMS, our equations have the same slope, but different, and the same y-intercept. Okay, and no solution, our equations are going to have the same slope, but different y-intercepts. Okay, so that is going to be the end of our lesson for today. Make sure you write down any questions you may have, rate your level of understanding of this lesson, and write down a summary of what it means to solve equations by graphing. On Monday, you will watch the video for another method, which is substitution, and on Tuesday, we'll watch the video for a third method, which is elimination. They all have their advantages and disadvantages, so we'll teach you 3 different ways to do these. All right, have a great night, guys.